Let us actually write this nicely. Let's write this more proper. And rectifiers convert AC input into DC outputs. I forgot one word. Pulsing. I will explain now what that means. So we get the from rectifiers, obviously. Let us start with the half wave. Half wave rectifier. So we have a half wave rectifier. We draw it like this. We have a transformer. We have the core. Then we have our diode. Then we have our resistor, our load. Then we have a capacitor here. Okay. So now we label this is our AC input. That's our AC input. This is our transformer. You can say this is actually our 230 volts. That's our 230 volts AC. This is our diode. Diode number one. This is our capacitor. And this is our resistor, our load. Then coming out here, it is our DC output, our 12 volts. So our AC input, our waveform is looking like this. It is just sine waves. Looking like that. So this is our input waveform. In this one, so this one is our output. Output waveform. So what this is saying is, so we must understand, do you know the biasing of our diode? Do you know what is the biasing of our normal diode, our p-n junction diode? Do you know the biasing? Forward bias. It is forward bias only, yes. So what that means is, for a diode to be forward biased, it means that whenever the input waveform is in a positive, you get an output wave in the or for that phase of the input wave. For the positive cycle, you get a ripple for the output waveform. When the input is in the negative, you get no output wave, so it's a straight line. You get nothing there. But when it's positive again, when it's in a positive cycle, you get a voltage or output waveform there. Okay, when it's negative, you get nothing again. Okay, so do you know this is all it is, right? So this is saying this. So it's conducting. Okay, D1 conducts, D1 don't conduct, like that. So then D1 conducts, D1 don't conduct, don't conduct. Okay, very straightforward, right? Um, so you can actually say that this is, we can say that this is forward biased. When it's forward biased in a positive cycle, it's reverse biased in a negative cycle. It's forward biased in a positive cycle and reverse biased in a negative cycle. So we know that our P in junction diode is only forward biased and will only conduct when it's forward biased. And let's tweak it out. Makes sense, right? Take me down on this one. Because that's all there is. That is all there is for the half wave. Yeah, this was actually in your test one. That was in the test one. Now we get a full wave. A full wave um, center tap transformer. Center tap transformer rectifier. It's a very, very long name. But it works quite the same. Okay. So we get our transformer's core. I want to throw it like this. I'm not 100% about this, but we do what we see. We see how things is going. Capacitor over there, and here we have a resistor. Okay, so now we label. This is our AC input, our 230 volts. This here is our transformer. This is our D1 and our D2. Probably drew it the wrong way, but okay. Our capacitor and then our resistor with our load. Then across this, it is our DC output, our 12 volts. Okay, so again, we get our waveform. We're trying to fit both in. So we have this waveform. So We have two diodes here in opposite directions. So um, the one will conduct when it's reverse biased, when it's in negative cycle. The one will conduct when it's in a positive cycle. So let me draw it like this. So when it's in a positive cycle, D1 will conduct. So then we get a ripple there. So we say here D1 conducts. When we're in the negative cycle, D2 will conduct. Then we get a ripple. Uh, like this. D2 conducts. D2, yeah. When it's in a positive again, D1 conducts. D1 conducts. When it's in the negative again, D2 conducts. It works like that. Okay. So, 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 so. So D1, okay, yeah, let's say it like that. D1 is forward bias, D2 is reverse bias, bias. Yeah, reverse bias. When the wave is in the positive, D1 will conduct. When it's in the negative, D2 will conduct. This is the input waveform, our output waveform. Okay, let's put the third one in. So this one is called a full wave bridge rectifier. So again, we have our transformer. Okay, so here we have our first. So here we have a diode that is like this, and the diode that's facing like this, and the diode like that, and a diode that's like that. Okay, this is going there, then here. Here is our load, our label. This here is our AC input, our 230 volts. This is our transformer. This is our D1, D2, our D3, and our D4, our R load. These across here is our DC output of 12 volts. Okay, so very same thing. We have our input waveform, and yeah, our output waveform. Okay, can't draw it now very nicely, but okay, let's just do it like this. So When we are in the positive, when we are in the positive cycle of our wave, our let me just get that right. Yeah, when we are in the positive cycle of our wave, our D1 and D2 will conduct because these are forward bias. Because let's say the current is going in here, right? The current is going in, it's going to the back of the diode, meaning like it's in the right it's in the right orientation. So it's going through forward bias. It's going to the front here, so it's reverse bias by D4. When it comes down by D3, it is reverse bias. When it comes down to D2, it is forward bias. So D1 and D2, it is forward bias. D3 and D4 is reverse bias. So when the wave is in a positive cycle, D1 and D2 will conduct. When we are in a negative cycle, D3 and D4 will conduct. We get that way. When we're positive again, D1 and D2 will conduct. When we're in the negative, D3 and D4 will conduct. So we write it. Um, so when it's in positive, D1 and D2 will conduct. When we're in the negative, D3 and D4 will conduct. When we're in the positive again, D1 and D2 will conduct. When we're in the negative again, D3 and D4 will conduct. So to write it, D1 and D2, it's forward bias. D3 and D4 is reverse bias. And over here, the D1, it's forward biased. Okay, now my question to you, sir. I didn't throw it in here actually, but let me see if I can put it in here. Do you have any idea the purpose of the capacitor in the rectifier circuit? Do you have any idea? Isn't the capacitor somehow Mm, yeah, yeah, that is perfect. That is not maybe perfect for definition purposes, which I suggest that you get a nice definition for that. But you are correct. You are correct. That capacitor, all this job is doing is going to something maybe like something like this, maybe. Yeah, something like that. It's gonna do just to try to make up for the shortfall that it's experiencing there. Something small. It's gonna do something small. Just something to smoothen out that output. Like this here. That's all it's doing. Making smooth, getting uneven. Yeah, also making smooth there, making smooth. That's what it's doing.